Hey, hello, everybody, and welcome to another episode. Today, we're joined by Youssef Mirini, solutions architect at Databricks, and all together just an awesome guy. Today, we're going to be talking about Delta Lake tips, tricks, and best practices, and a lot of just wins from the day in the life of. So I'm going to kick it over to Youssef if you want to say hi to everybody and just give a good warm welcome.
Hi, I'm Youssef. I'm based in Paris, and I'm a big fan of Delta Lake. I've been using it for, I think, more than 4 years. So I've been noticing all the revolution inside Delta for quite some time.
Awesome, thanks for that, dude. So yeah, well, let's kick it off. We're going to go through some slides today, and then we'll take some questions from the audience. All right, perfect. So, Youssef, I don't know if you want to take control.
Yeah.
We'll go through. Awesome. So yeah, so for the whole entire session today, we're essentially talking about it's like almost like a back to basics. So we're talking about tips and tricks, but a lot of this is kind of based on what are the things that people would need to do or want to do, within the first couple months of working with Delta Lake. And like one of the big things that people usually need to first understand is like, how does Delta Lake actually laid out? And so on the slide right now, we just have, essentially kind of table layout 101. So this is just a typical looking partitioned Delta Lake table. We've got partitions by event date. These are from way back in the day, from 2019. And all of our actual data files for our Delta tables are just Parquet. Then we have our transaction log, not our transition log, our transaction log, which is actually keeping track of what happens every time there's like a commit to the table. And so this is what gives us like our ACID guarantees. This is what allows us to have multiple readers, multiple writers on the same exact table. It's essentially kind of coordinating things for us. Within the log, we have all of our metadata. We've got information about the table itself, what schema it has, what partitions it has, what other kind of table properties it has as well. And then we have essentially checkpoints. So as we're writing transactions, periodically, we're creating snapshots so that it's easier for us to be able to go back to a certain point in time and or to load the most current version of an individual table. So you put it all together, you've got a Delta table. And now on to the next one.
Yeah, and just to go back to what Scott was mentioning, my advice would be go and open the JSON files and see what you have inside. And then also open the checkpoint, which is the Parquet file, just to see how it looks like. It will give you an idea how Delta tracks every single modification you're doing on your table, like by modifying, adding, you're gonna see the structure, some interesting information. So I think this is the basics, but make sure to have a look at it.
Wonderful.
And I guess for this one, I wanted to touch down on the Delta Lake clones, because those are very awesome features. The first one is the shallow clone. I think it's an underestimated feature. This one is super important because it allows you to clone a table or just cloning just the metadata without having to copy the entire table. So let's suppose you have, 1 terabyte table. You want to do some modifications on it, but you don't want to copy the entire data. So what you can do, you can just shallow clone it. And then you can do any modification, and you are sure that you won't be modifying the system, the source table. So what will happen? Like if you modify, do updates where value equal to, to Paris, what will happen? The shallow clone table, only the modification will be added to the new table. The existing one will remain the same. And this is an awesome one because you can use it for short-term experiment without having to pay large fees for copying the data or moving the data. And you can also see in the shallow clone table, like the new table that has been created, only the modification, which means if you update, for example, one row, the unique row that will exist in the shallow clone table will be the row that you have modified. And the existing one will be the same. But just keep in mind that if you modify the source table, the shallow clone table will remain the same, because when you do shallow clone, it's on the latest version. For example, it can be version 7, which means if you modify or update the source table, it's going to be version 8, which means on your side, it's going to be the same the same version. Just keep in mind that if you vacuum the table and remove, for example, get rid of the version you're talking, then the shallow clone table will no longer exist or will be corrupted.
Which is a really good, I think, a good kind of segue into thinking more about like how long you want to retain, a table for in general. I think that's also a good, your call out for like having this as like short-term experiments. It's also good if you're playing around with like new table properties, or you want to test, different ways of like, organizing the table's metadata, or, it's like maybe I'm thinking about different, I care a little bit more about, some specific table properties, or I want to try, something new. It's always kind of nice to have like that, almost like that playground to go test in, that's not affecting the actual table that could be, producing, it could be responsible for production data, for example. So yeah, shallow clones are awesome. But the next one I think is also really cool too.
Yeah, the next one are deep clones. And deep clones are a bit different from shallow clones. So over here, we're gonna copy the metadata and the data as well. So this one is pretty straightforward. You can specify the version you're gonna deep clone, but the good thing is gonna create a new delta log, which is good. And when should I use, for example, deep clone? Let's see, for example, let's suppose you want to do some data archiving. For example, you're doing a lot of modifications on a specific table, but the regulation specifies that you need to keep a snapshot every month. So what you can do, instead of having to keep this copy, like all those different versions, you can just, for example, deep clone the latest version on, I don't know, at the end of each month. Or if you want to, for example, clone the table, like copy the table to put it somewhere else in another catalog or schema, you can do clones, and they are super efficient. And I think it's really a great way to leverage those two features: shallow clone and delta lake clones, and of course the APIs in the screenshot, like with C, can use it with SQL and Python as well.
Yeah, I think the other thing too that's interesting, like outside of like data archiving and like just kind of data migration itself, for people who have to do anything with like legal hold is also another nice thing for deep cloning, because you can take a snapshot of exactly what the table looks like at that point in time, go move it over into your long-term storage for like the 7 years for legal hold, and then continue to move on with your life, removing data from that table as if you didn't actually have to keep track of anything else for legal hold. We also do have a question from Alex. This is coming back for like the shallow clone table. And so the question is like, for a shallow clone table, like the query is on the original data set, but it shows the affected rows in the shallow clone table. And it is correct. So like it's essentially kind of like a pass through. So you have your original table. So let's call it table A. Table A has all of its parquet for that specific version that you created the shallow clone from. The shallow clone will still be reading all those files unless they disappear. And that's like that whole kind of problem where, because it's kind of metadata only changes, going back and reflecting off of what the table was, if that changes, then you're kind of stuck. And so, yeah, it is supposed to be used for short-term experiments as well.
Yeah. And something I want to mention for the clones, you can clone, like you can deep clone the same table multiple times. For example, you're going to clone the latest version on, for example, the 1st of April, then the same table in the 2nd and 1st of June, and so on. And then you can, for example, describe history. You're going to see all the different versions you've deep cloned for example, for legal reason, or for as Scott mentioned. So the clones can be a very good options.
Oh, for sure. Yeah, given that you do have that transaction log. All right, moving on. Take it back over.
Yeah, and I think this one also, log retention duration. I think it's also a very important feature, because people tend to confuse log retention and another table property that we will be talking about it in a few minutes. So log retention, by default, it's fixed to an interval of 30 days, which means like every single modification you're going to be doing on this delta table, you're going to keep the logs there. Like, for example, that you updated the table, you deleted the row, you inserted the new columns, you will be able to track those modifications, to track the logs for 30 days, which means if you want to track, for example, to go back in time for 60 days, you need to make sure to modify this log retention duration and put it, for example, if you want to keep the logs for, I don't know, 2 months, then you need to put here interval 60 days. This is very, very important. And it's the only way to help you perform this time travel queries. So this is, but that's not the only requirement. We still have another requirement that we're going to be checking a little bit later.
I think there's a good kind of buried lead right there for that. So yeah, do you want to move on? Well, we can circle back to this afterwards. So.
And also this deleted file retention duration is very, very important. Why? Because you're gonna, from time to time, and this is something also you need to keep in mind, you need to run the vacuum because the system does not run the vacuum on our behalf. So all the old snapshots you created across time, I don't know, for 2 years or 3 years, are not dropped. So you need to make sure that you run this vacuum to get rid of all those files. But to do so, what you can do, you can specify this deleted file retention. So here you're mentioning that you need the minimal duration to keep those old snapshot will be 7 days. It doesn't mean that the data that was created 1 week ago will be dropped. No, I'm talking just about the snapshots. And what you can, by default, it's set to interval 1 week. But you can, for example, put 2 weeks, and whenever you're gonna run the vacuum, automatically it's gonna keep just the last 2 weeks of snapshot. So this is something you need to keep in mind. This is in the case you don't specify the option when running the vacuum. But since people does not do this before more often, so make sure to specify this interval and make it suitable for your project. And keep in mind that the vacuum is very important because at the end, if you're storing your data on a data lake, which is in an ADLS or an S3 bucket or GCS, you're going to end up paying some money for nothing. So that's why I think you should leverage this deleted file retention.
I think with that also kind of going back to like the log retention, it's an interesting thing if you want to go back to a specific point in time as well, and you have a deleted file interval of 1 week, and you have a log retention period of 30 days, and you want to go back for 30 days, and you've deleted files, there are certain files that you're not going to be able to get back to. And a lot of times like this happens because you don't have deletion vectors on, you're removing specific files from older Parquet. And then that's every time you have an operation that is changing or mutating a specific point in time, it's going to create another Parquet file. And essentially it's going to orphan the older Parquet file with the new, it's no longer going to be linked to the new current snapshot. Like what does the current table look like? It no longer references that file. And so in a lot of cases, if people don't clean up the older files, you'll have this entire, this entire life of this table that no one knows about anymore. And so, in order to, balance what you have in your metadata, to balance what you have in the transaction log, and then to balance what you have in terms of kind of orphan files that are no longer connected to the table, you have to play with both of these together. So it's another thing that can also be tested with deep cloning, with shallow cloning, just testing the different properties. If you want to be able to go back and say, I want to try different settings for time travel, because in that case, you can continuously just kind of create new tables to test with in a safe way, which is fun.
And for the next one, it's more about the optimization side. So over here, we have what we call the data skipping num-index calls. This feature is, let's say, very, very important because that's how Delta will capture statistics that will help the engine when running the query to improve the data skipping. And by default, it's fixed to the first 32 columns. But you can, for example, if you don't need to keep, for example, suppose you have, I don't know, a table with 50 columns, but the most important one are the first 3 ones. So you can just, for example, modify and put data skipping num-index calls equal to 3. So to make sure that you don't run some computes just to capture statistics for some columns that you want leverage or benefit from. But this feature is very, very important. It's part of the when you run the optimize. And you got to see that you have a bunch of other properties that are linked to this one in order to improve the efficiency of your queries.
Yeah, I think I'm glad you brought up the notion of like, if you only need 3, use 3. Like you can also turn off like data skipping if you're just doing like append-only tables and you don't need to do anything special with it. If you're just using like a snapshot mechanism, saying this is the table as is, we're never going to do anything with it. It's kind of like, here's a sealed data set. But I think it is really important to be able to think more about like, there is a cost associated with like 32 columns worth of statistics, especially if that is being calculated on every single micro batch as well. If you're doing things in stream or every single kind of gigantic batch, if you're doing, kind of large batch style operations. And so if you're never going to use it, like there is that compute cost to that. There's also storage cost to be able to, keep track of the statistics over time, which is important to know. Oh, so this just actually came up. It's like, what's the cost of collecting statistics on too many columns? It's just time, right? It's time.
Larger optimize. So optimize will take more time because you need to capture like, I don't know, the mean, the max, and so many other metrics. So larger are the bigger or longer are the columns, longer the optimize will take. And if you're paying for the compute, then it's gonna cost a little bit more.
Yep. And I think one last thing, but like before we move on from this one, the first 32 columns, if you have a nested table, will essentially do a depth first traversal. And so you'll be going down versus like across within like the table itself, which is something that's sort of a gotcha, depending on how people are creating their tables. So if people are, enveloping specific data across a table with a, kind of deep sub-nested columns, you might be surprised at what actual columns you're indexing versus what you think you want to be indexing as well, which is just an important thing to keep in mind.
And I think we have another question. Does it affect querying as well?
Yep.
So of course, I mean, if you won't be using those columns, so it doesn't make any sense to run the optimize on those columns because you won't be benefiting from those statistics. But of course, if you know that you're gonna be, I don't know, running queries on the, I don't know, the last column on your table, which is, I don't know, the column number 30, then yeah, it can be a good option. But we have other optimizations technique that we will show you in few that can help you reduce this number of columns that you will be leveraging.
Yeah, but I think as well for that, like, so for the question of like, does it affect querying? It definitely affects querying as well. So there are certain cases where if the entire query can be just pushed down to the statistics themselves, you don't have to open files before actually having all files that can be returned for an individual query. So you think about like, there's like partition pushdown, like predicate pushdown, anything that can be pushed down to the columns, like to the actual statistics themselves, is beneficial for speeding up your queries. And so for very large queries, if you don't have the stats columns, then that will be a lot slower of an operation because you have to scan a lot more data. And so it is very much something that will help, speed up those queries as well.
And yeah, the nested one when it's nested, it also accounts as an additional columns, and you need to pay attention to this.
Yep, 100%. Awesome.
And the next one, I wanted to talk about this ordering, like updating the column order. It's important because you can link it to the previous one. So let's suppose you have like all the interesting columns that you're gonna be using are, I don't know, located in the last columns of the specific table. So what you can do, you can try to alter, if you want, of course, alter the order of those columns to make sure to push them at the beginning of the table. So you can, for example, mention, hey, capture the statistics only for the first 8 columns. But that's not the only thing. I've seen some customers and users who change the order of columns just for the sake of readability, because they put the date at the beginning, because this is how they query this table on their head. Like, I want to, for example, filter by country, for example, France, and then by city, then by date. So they order the columns, make sure where it helps them read them. But of course, you can also change the order of column to make sure that you put the one that are interesting at the beginning. So when you mention the num-index call, you specify 2, 3, 4, or depending, of course, on the number of columns that are important to your queries.
Yeah, and this is also, I think, for people who haven't used Delta before and are coming just from like standard Parquet, this is an operation that was like unavailable like on just Parquet itself, because you had like ordinal offsets for columns. And so if you were querying by specific table, like columns, and they reordered, then your older queries would fail because they would no longer be in the same spot, which is also not a thing that Parquet allows you to do. And so in this case, like with Delta, you have an overlay over that, which is just saying like this human readable column name is associated with this index. And then over time, like this is where like column mapping comes into play. And I think we have another slide on column mapping as well. So kind of just, that's where this comes in.
And the next one, this one is also linked to what we have mentioned. It's the data skipping stats columns. So this functionality will overtake the old one about the number of columns that you will mention to capture statistics. This one can help you get, for example, if you don't want to reorder the columns on your table, what you can do, you can just specify the columns where you want to capture statistics. So you will specify, for example, I want to capture column 1, column 3, column 10. So you're going to target those columns and to make sure that you are not paying additional cost to optimize non-important tables. And you don't want to change the order of tables because maybe it's used in another tool that can break in case you change the order of columns. So this one can simplify your life. It's the data skipping stats calls. And you can mention the columns and it will help you optimize the query performance in a very simple and efficient way. And it's mainly used for wide tables, because if it's small ones, you can use the number of columns, but this one can be very, very interesting.
Yeah, and I think the other interesting thing too here is that, so given that the columns also support like nested column like dot notation, if you want to be able to specifically like index on subcolumns of a nest, you can do that as well. It really just depends on the style that you want to move forward with. And then just make sure that you don't break that if you're changing the schema. And so, there's specific kind of, in this case, like if those columns go away, it's just going to stop keeping statistics on it. But just something that's kind of worth noting as well. You think about like the data skipping stat columns being essentially like, required columns, which is awesome. Okay, let's see. We're gonna also, we'll take a break for just a sec. We're gonna answer a couple different questions as well. All right, so let's see. So yeah, the slides will be available at the end. We can post them after this is complete as well, just in the comments. Let's see. Okay, so does updating column order require rewriting the entire table in Delta? And this is just a mapping.
Yeah, just the metadata behind the scenes. You're not rewriting the data, just updating the logs.
Yep. Yeah. So it's just, metadata only is a great way to reduce like the overhead of a lot. Awesome. Good question. Thank you. Awesome.
I think we have another question. Could you elaborate a little bit more on move such columns to positions beyond the index specified by this property? So if we go back to the previous slide, so what you can do, you can, for example, let's suppose you have, I don't know, your table is 50 columns. You have 50 columns in this specific table. If you run the optimize, by default, it's going to capture the statistics for the first 32 columns. But what you can do, you can move the important columns to the left, to the left, and then you can just, for example, if you move 5 columns and those are the important one, you can just say, okay, capture statistics for the first 5 columns, and that's how we can reorder them. And you can use, for example, as I mentioned, alter table, alter column, and put this one first, then this one second. But of course, it's gonna take some time because you need to do it for every single column, or you can replace multiple columns at the same time. So that's what we mentioned by reordering the columns.
Yep. And I think the other interesting thing too there would be, so if you've already captured like column or statistics and you want to go back again in the future, like they do have like optimize full as an option. So if there's been large changes made to the column mapping and you want to now go grab stats for the whole table, you can just go and basically re-optimize. There's also the analyze functionality as well. And I know we don't have a slide for that as well, but you take a look at just Delta Lake analyze. ChatGPT will show you exactly what to do.
Yeah, and the analyze I've tested before. It's super interesting because you can run describe extended or describe details on a specific column. You will see that you don't have any statistics. But once you run the analyze, you're gonna see, for example, for a specific date, the mean, the max, the number of types and stuff. And this analyze will help the Spark execution plan to be more efficient. So the skipping will help like avoid having to read all those files, and the analyze help the data skipping, the Spark execution plan. So that's why the analyze can also very important to use. And the next one, I think this feature is very important. It was introduced, I think, 1 year ago. Deletion vectors. And basically, it's introducing the merge on read feature. So basically, as you know, a parquet is immutable, which means whenever, for example, you modify anything, it's gonna create another file. And if you're doing like a lot of merge, like insert and update, you're gonna end up spending a lot of time just rewriting maybe the same file multiple times. So deletion vectors works with let's say, a smarter way, because it introduces a bitmap marking the files that need to be deleted. It doesn't do it immediately, but it waits a little bit later when it's required, which means rather than operating like, recreating the files 4 or 5 times, it can only be done once because it's marked and don't need to rewrite those files. And this feature is very important in case you're doing, as I mentioned, a lot of frequent delete, update, and merge, because you're going to significantly reduce the execution of those specific workloads. So you need to make sure to enable deletion vectors.
Yeah, this also saves a lot of so aside from the other benefits as well, like if you're cost conscious as well, you could test both of this, but without deletion vectors, the number, like that whole number of files, like there's just a lot more that needs to be vacuumed and cleaned up after the fact as well, because you're going to be orphaning a lot of individual files, especially if like there's no no Z ordering or any other kind of clustering involved with the table itself. A lot of like the point deletes end up being extremely expensive. Like if you're, if I'm like removing like 2 or 3 columns per operation, it can significantly kind of like increase like the cost of, just operating a table in general. Hold on. So, all right, there's another question, which is just, wasn't really a question. It's more just like optimize does not trigger analyze. And that's correct. So like the analyze functionality itself will go back and capture the statistics as part of writing, and whenever we're doing like an add files or any kind of operation like delete files, anything else like that within each individual transaction. The end of the transaction is where the statistics are being captured before commit occurs. And so like optimize is what we want to run when we're going to like remove kind of orphan data or, older like snapshots of the table over time. And then analyze is only if we have missed running any kind of analysis. So for example, like if we had no, if we weren't capturing any statistics, and then we wanted to go and turn on statistic captures, like we have to go back and, either get statistics from the entire table. So go back to the earliest point in time and then go analyze our table, and or say, okay, it's fine. Like from this point forward, I want to start capturing stats. I can change my table property and then start capturing the stats from that point in time onward, anytime a new batch is actually, appended to the table, or any other operation is, applied to the table itself. So there's a couple different ways of doing that. So thanks for that call out as well. And let's see, we have another one from, let's see. So we have, let's say we have a streaming job which continuously keeps adding the data to the Delta table as append only mode. So if the optimize is happening automatically, then which compute will it be using? If it's a job cluster, then it's going to be in the job cluster, like for that optimized. If it's, I'm guessing this is like the Databricks auto optimize functionality for this one. And that's going to happen, like if auto optimize is running, it's going to be doing compaction like every 10 jobs if it's running in streaming mode. So you'll see like an individual job that runs. So I'm thinking about this from like a workflows perspective. There'll be essentially just a new job that's inserted into that flow that will be going to run like that compaction as well. It really depends on if you have like the right optimizations on or just kind of auto optimize, like auto compat on as well.
Yeah, I think default one is 256 megabyte per file, if I'm not wrong.
Yeah, and so that can be modified with different settings as well for that. But yeah, and so the second part of the question too is like, so if it is running on the job cluster, then does it mean it will also increase the overall latency of the streaming job, as they'll be running optimized after each micro batch execution? And it will reduce your ability to go like as fast as possible, but on the kind of you're paying it forward, I guess, is the best way to say it. So for anybody who's like downstream of that table, if they were to go back and have to either read, suffer under like the small file problem or anything else like that, like depending on like how quickly the streaming job is actually appending new batches, like it's better to be able to, solve the small file problem once and then have everybody downstream of your streaming job actually, benefit from that as well. So while it does increase the overall latency, it's only at one point within the lineage.
And I think we have an interesting question about does the vacuum also remove the delta logs? So basically, no. The vacuum will only remove the Parquet files. It does not remove the logs. So the logs are deleted automatically and asynchronous. I always struggle with this word. Synchronously.
You got it.
By the Delta Lake, by the Delta Lake engine, and keep in mind that the logs, you specify how long you want to retain them. Keep in mind that, as Scott mentioned at the beginning, whenever you write 10 commits, it creates a checkpoint, and then those files are deleted. Because think about every time you run a command, you run a modification, it's a new JSON file. And what if you run 10,000 files? It's gonna be a long number of JSON. So it's done automatically. And after each 10, it creates checkpoint, and then it deletes all JSON files automatically. But the Parquet are not dropped. You need to run the vacuum.
Awesome. I think we're good. We're good with questions for right now, so we can move forward.
And the next one, I think also underestimated feature is the change data feed. So it's really a simple way to run the CDC on Delta. And it's just keep in mind that you enable this feature only and when only it's needed. Why? Because it will increase the size of the table, because all the data it retains behind the scene. But then it's a very cool feature, because if you don't enable this feature, you're gonna see the different version for each table, but you cannot find like what did change in the meantime. But with this one, you can just run the command, select, and you specify the version, for example, starting version 1 and version 3, and you're gonna see like two different rows, like the first row, for example, Youssef, Mirini, V1, and then you're gonna see Youssef, Haines, V2. So you know that okay, what did change is the last name, and it simplifies, and you know that this is V2. So, and you can also see the type of operation, whether it's an update or insert or delete. So you can filter by specific version, you can filter by specific operation to propagate those modifications to another table. And it's really straightforward, but just keep in mind, do not enable it everywhere, but make sure to enable it only when it's needed.
Yep, 100%. I think with a lot of these things, right, it's, you opt in, you have the ability to opt into these specific like features, when they're necessary. But for anybody who's had to do like CDC any other way, like the change data feed makes that a lot easier, transactionally, given that, the upstream table only has to enable it for the downstream to be able to consume any of those changes. And so for a lot of like those change feeds, there's a lot of other ways of kind of tracking changes that become a lot more problematic. And so given this is built directly into like the protocol, and it's also built directly into like, the Spark ecosystem, for example, like I can go and read the change feed, and that makes it a lot easier than having to just go read the table and then, hope that somebody has, enabled, some sort of, homespun tracking themselves. Like anytime something is at the protocol level, it's a lot easier for everybody because it's standard. And so it's very nice in general. Okay.
So we have a question about liquid clustering. I think that we're going to keep it till the end since we have a topic about it.
Yep.
Yeah, and this one, column mapping, I think when it was released, I don't know, 2 years ago maybe, it's a very interesting feature. Why? Because it helps you avoid rewriting the tables. Now, it can give you a simple example. In the past, for example, if you want to rename a column or drop in a column, you had to rewrite all the table. And what if the table is, 1 terabyte, 2 terabyte big? So it's going to cost you a lot of resources to do so. But once you enable column mapping, you can do this, and those modifications will be propagated at the metadata level, which make them very easy to be modified. And this feature is also very important because it's also, I think, super important to enable another table properties. I think deletion vectors require column mapping, if I'm not wrong, but it's a very important feature. And that's not the only thing. You can also use column mapping. Again, it's not recommended, but you can have space or special characters in the name of the columns. But again, be cautious, because if you have space in the middle of, two name, auto feature, you know that you have a space, but what if this space is at the end of the column? So be cautious when you're using special characters. Parquet does not allow them, but with this column mapping, you will have this opportunity.
Yeah, and that was also for this one, it was protocol version 5 where this came out. And so I think this was like Delta 2.3 around then. So it's been around for a while, and I know we covered it earlier, like in the talk as well. But back in the day, like with just native Parquet, it was a lot harder to do these things, just because you didn't have a map over where the columns were. So there was no kind of interface between like the offset of the column, like 0 through n, and the actual like human name that you would want to apply to that as well. So it just made our lives a lot easier. Awesome.
And this one was also, I think, super interesting, which is the allow columns default values. So basically over here, you can create a delta table, and you can specify for each column a default value, which means whenever, for example, someone is doing some insert and is not, filling the specific column or those columns, then you're good to go. You don't need to fill them. And you can also think about it in a way, for example, let's suppose you have a table, and every time someone is doing an insert, it should capture, for example, the current date. So what you can do, you can just specify current date as default value for this specific column. And then whenever someone is doing an insert, it's automatically capture this time date, this current date or timestamp. And it also avoid, for example, having to provide, I don't know, to have those empty columns that can maybe cause issues for some systems, depending, of course, whether you're reading data from Spark or any other engine. So, for example, you can specify the age, I don't know, the median or default value for some car maker. So, just for the sake of having this clean data on your tables, and I really advise you to use it because it can also help you clean your data sets. And this one, I think, this generated column, I think it was super cool, and I used it first with when I was partitioning my tables. So basically, what I did, I remember I have a birth date, and it was a timestamp. So what I did, I computed 3 additional columns. That was month of birth and year of birth, and those columns were computed from birth date. And then I was using those 2 columns to partition my tables. And you have 2 options with those generated columns. You have the generated always, which means you're gonna always generate this, or what you can do, you can generate by default only if this column is not filled with data. So this one can be very interesting, and you can make sure to compute columns without having to add like additional things behind the scenes. So I use it a lot, and I think we have 2 features. It's generated columns, and the next one are identity columns. But keep in mind that this feature is very efficient, and you can also use it for to partition your tables.
I think the other thing that's really interesting too, from like the last 2 slides, is that like in a lot of cases, there's a lot of things that the protocol itself can do, like writing into a Delta table can do automatically for you. That removes a lot of like the work that occurs in a lot of like ETL pipelines. Like it's like I am getting specific values. I want to expand on those values to create like these subset columns. If you think about that being like a typical day in the life of a data engineer, if you can automate that, then there's no need to ever be like, oh, what's our data quality metrics for this? How often are we missing, month of birth, year of birth, or anything else like that? It's like, well, if you have that timestamp, who cares? You can take that timestamp and you can go and you can, automatically always have those values you need. And so it really reduces a lot of that level of effort for, utilizing Delta in general.
Exactly. And the next one is tightly linked to the first one. It's identity columns. And this one, I find it pretty interesting because you can generate unique values. You can think about, as I showed in the example, I create let's say primary keys. You can specify the range, for example, starts with 0 and increment by 1, by 2, or whatever you're thinking about. Just keep in mind that when you're using identity columns to create unique keys, it cannot be parallelized. It's only a single node, because for this specific one, it needs to keep the track of the values. But trust me, I use it with 30,000 values, and it was created the unique values. But it can be a little bit slow because it cannot be parallelized. That's because you need to make sure that those keys are unique, but you can use it as a primary key, and you're sure that you have generated the unique values.
Well, I think this is something that's like really interesting too, because I think for a long time this wasn't a feature, and this was like people asked about this a lot, right? Where it's like, how do I treat Delta Lake, or how do I treat my Delta Lake table like I would a traditional kind of transactional database? And in this case, you now have that ability. And the nice thing too is that, like, if you think about being able to call specifically, what are my primary keys, or what are these identity keys, like surrogate keys, etc. Being able to call those out specifically within like the metadata also helps people like attribute that to something that's will always be here. It's always generated, and it's something I can always refer to. And so it's like a kind of stronger key, right? It's like, I will always have this. It's always required. It's generated for me. And so then in the future, you can join easily off of those, those rows themselves. And then the nice thing too, going back to like the stats columns, is that being able to keep track of like our min max values across like our primary keys gives us the ability to basically skip those offsets as well. So that really helps with retrieval of specific kind of points where we have these identity columns as well.
And last and least, we have liquid clustering. So it's also, I think, it's a modern way to optimize your data layout. And I find it interesting because it can replace the traditional partitioning. In case you're not sure of which column you're gonna be using, maybe for example, now you partitioned by date, but you wanna add later maybe country. So you would need to rewrite the underlying data. While with liquid clustering, you can just alter table and add alter table cluster by and add 2, 3, 4 columns. And I think also liquid clustering is very important because when you run the optimize is going to be running will be only on the incremental data. And this is super, super efficient. You won't need to spend several times like waiting for the cluster to compute the optimize specifically on super, super large table. You can, of course, you can create like those liquid tables easily. You can alter an existing table and create liquid cluster. But keep in mind, if it's partition table, then you would need to use setas to create a new one. If your table is not partitioned, you don't need to rewrite the underlying data, and it's very efficient. And the order of the clustering keys does not matter. But keep in mind that you won't be using 5 columns as the clustering keys. Keep in mind that it's just like using partitioning plus the ordering. You won't be partitioning by, I don't know, 5 columns. You always going to be using maybe 3 columns, and the last one can be the order. So those are the columns that can be good when it comes to choosing which one can be a good option for the clustering.
Yep. And then we also had, we have like 2 other sessions that we had done before as well. If people want to deep dive further into liquid clustering, we had like the beyond partitioning, then we had the hybrid clustering session also, where we went into a lot more detail on like the kind of the hows, whys, the do's, the don'ts with using liquid clustering itself. So with that said, we also have a ton more questions that are coming through. And so, well, yeah, this is a perfect slide for that too. All right, so let's go back down. Let's see, where do you want to pop into? So hold on one sec.
Oh, okay, so the first one is very interesting. It's the ingestion time clustering. So for the ingestion time clustering, basically what happened is that whenever you're like writing some specific data, this data is written on a specific time. So basically, it's like that this table is clustered or optimized by default because it's ingested in a specific time. For example, I don't know, at 2 p.m., 3 p.m., 4 p.m., 5 p.m. It's like being, let's say, partitioned. And Spark in the past, because of some properties, it didn't respect the order of the insertion. But now they make sure to keep the same order as much as possible, including, I think, when you have the merge operation as well. But that's how it works. So since the data is ingested at a specific time, so it's like it's ordered, and it's like having the natural data skipping. Because if you specify, okay, filter the data from, I don't know, where the hour is equal to 4, so you know that you don't need to scan all the table, just go to the specific index. So that's what we call this talk about this ingestion time clustering.
All right, and there's also, yeah, so we already answered the data skipping stats leverage and the Spark joins and Delta table merges. We didn't talk about it as like a Spark join in general, but anytime that you have the index column, because you can easily prune what files need to be read, it does help with like those joins themselves. Same thing with the merges. As long as you have that data in the actual in the Delta table stats, that speeds up that whole entire process. So think of that as it's a lighter weight, it's a lighter weight index, but it still will help in the same way that you would typically have an indexed column that you're joining off of to speed up a join with like a traditional database as well. All right. Let's see. Do we want to, will the identity columns and generated columns as features, where exactly can we find the functionality being applied on the table? So for this one, like for Rama, if you go and you create a brand new table and you specify a column as generated always as, and then you could apply pretty much any kind of condition you want in there. Once you have the generated always as, anytime you add any row of data, you can do this all within a notebook. You could do it in a Jupyter notebook. Doesn't really matter where you're doing this. Just add a row of data, and you're only filling in the columns that you need to fill in. Everything else will magically just show up. So for example, a lot of times if you're reading data from Kafka, you have the timestamp from the Kafka broker from when new data was written. If you're using that to create a partition key, with the old Hive style partitioning, you can do generated always as date to project that timestamp into a date value as well. And then that column will always show up with your table as well, essentially utilizing another known column that will always exist as well. So you don't have to explicitly do anything. You can ignore it and pretend that column doesn't even exist, and it will always just show up for you. All right. Let's see. Do we have? Yeah.
I think another one is there any way to prevent optimizers from breaking due to some concurrency errors? So basically, if your table is partitioned, you can make sure to optimize only some specific partitions. And if you are using liquid clustering, you have the row level concurrency, which was introduced with liquid clustering, which reduce also the possibility to face those concurrency errors.
Yep. But I mean, in certain cases with that too, we'd covered a little bit of this, when we were talking about the hybrid clustering before. There's use cases, there's kind of edge and corner cases for a lot of things too. So if the process is running and it's optimizing, the way that Delta works is it's multi-version concurrency control. So you'll be doing an optimized flow on a specific version of the table. And if new additional changes have been made in the next version, then that next version being applied to the table won't actually take, that won't be applied into that current optimization flow, but it will be the next time the optimize process is run, because it's incrementally being applied. And so it's not going to stop new changes from occurring while the current optimized flow is going, if that makes any sense. So there's no distributed lock, for example. Let's see. I don't know what some of the other questions are. Let's see. So there's a longer one. We've got a couple minutes left. So it's I have a complex job pipeline in Databricks where tasks are dependent on the upstream tasks. Meaning a task only runs after its preceding task completes successfully. Say we have workflow 1 within it, task called task A. We also have workflow 2 and task B, and the workflow depends on the successful completion of task A and workflow 1. John is how can workflow 2 know or auto? So you're talking about this is kind of this is a transitioning from kind of an airflow mindset to workflow mindsets. If you wanted to have if you had workflow 1 which had task A in it, and then you have workflow 2 with task B, and task A from workflow 1 is the dependent task in task B. The question I would propose is, can task B exist within that workflow? Because like if I have a workflow and that's like workflow A, and task 1 is doing a lot of like preparation for that task B, then I can also keep task B in memory within the same executor within that workflow. And so then the read is essentially free, because I'd have 2 tasks being processed within like that workflow, as long as like we don't run into memory constraints or anything else within that workflow. So you might actually speed up the workflow by having task B just be dependent on task A finishing within like a workflow, without having to create any sort of like workflow dependencies, which always add more complexity to the jobs themselves. But yeah, there are other you've got different triggers like in the workflows as well. So if you're waiting for a specific file to exist, there's different ways of triggering different jobs to run. But unless like there's a need for the additional complexity, it'd always be easier just to, tightly couple that back into that workflow. That's my 2 cents.
I think we have a question, but I believe you might have answered it during the last session. In which scenario should we use auto-liquid clustering and hybrid clustering to get optimal runs? And does hybrid clustering also deletion vectors auto-enabled, or we should enable it manually?
Yeah, so this one, the interesting thing, so the hybrid clustering was more of like it was a name. It was a name and more for the thought experiment of like how we connect essentially Hive style partitioning, which is a type of clustering, like which can lead to a type of clustering like Z order clustering or kind of traditional bin packing optimize, versus liquid clustering, which is more efficient than say like a Z order like index on a table. And so for like the hybrid workflows, like that's essentially up to the user, right? So we talked about it more as like this kind of like end-to-end lineage where we had specific tables that had essentially like a close of books time period. So if we're waiting for changes for a certain amount of time and we want to be able to have like write isolation within specific partitions, then that makes a lot more sense for classic like partitioning, like the Hive style partitioning, because the optimizations we can make are very specific to specific partitions. When we're ready to essentially have a table that's long lived that can benefit from like liquid clustering, then at that point in time, that new table becomes essentially liquid clustered. So we're essentially just changing the time to live for these different tables. And we have that up on YouTube as well, just the hybrid clustering for that, which goes into a lot more detail as well. But you would only add deletion vectors if you need them for those use cases as well. So in the case where you're overwriting a lot, you can have the deletion vectors on like the classically partitioned data. But if you're essentially moving into append only for your liquid clustered table, you might not actually need deletion vectors if you're not actually deleting anything. And so that's like just another thing to keep in mind. Like if you're just essentially deleting, data that's older than say 120 days or 90 days, or whatever, then deletion vectors aren't going to help as much because you're not modifying individual Parquet files, which is causing a lot of trouble. You're essentially just like truncating a table to a specific point in time. And so for a lot of it, it's just contextual, what solution to pick and go with.
And I think we can answer one more question and we can close. I think it's related to liquid clustering again. Is traditional clustering more effective for batch workloads since liquid has a dynamic approach? Or like since liquid, and then we have dynamic, is liquid also a good option for streaming since it has a dynamic approach?
I think, for this one, do you want me to answer it? Youssef, do you want me to pick this one up?
Yes, please.
Okay, cool. No, I was like, all right. I'm like, I could do this. So I think with this, when we talk about like kind of like a dynamic approach for anything else, right? It's like, do we need to make a decision up front? Is there a reason for us to think things through beforehand? In a lot of cases, like with the old style, which is not bad necessarily, but like with Hive style partitioning, you had to really think through like, what's the layout of my table going to look like? What does it look like now? What does it look like in 6 months? What does it look like in a year? because if it's a gigantic table, any kind of changes that are made that need to relay out the entire table were costly. So with liquid clustering, you don't have to cluster until like your database table, for Delta gets to say, 20 gigabytes, 100 gigabytes. Then you can start thinking about like, what are like the use cases in which we'd want to cluster differently so that like our queries are faster. And that's essentially that's something that you can then incrementally apply to the table, which can help. And that's where like the optimized full comes in. So if you haven't made a decision, then you want to go and change like the cluster by columns. And then you want to go back and reorganize like the files for those clusters. Then that can be done like one large run. Caveat being if the table is gigantic, that job might take a long time to run. But that's it. I guess it's dynamic in that you have a choice that you can make later.
I guess that's it.
Yeah.
It was awesome to be here with you. For those who posted questions on LinkedIn, I'll make sure to share with you the documentation and the useful links, and make sure, of course, to download this awesome book written by Dini, Scott, Tristan, and also Prashant, Delta Lake Definitive Guide. You can download your free copy. Just scan the QR code or just look it down in Google. I think you're gonna find it easily. Or go to the Delta Lake documentation as well. You'll find it there.
Awesome. Thank you so much for coming on today, Youssef, and for sharing like the tips and tricks. And it was great having you today. So cheers, man. All right, bye, everybody.
Thank you.